Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and concepts. So let me know like if in case you're gonna have any doubt anywhere in the discussion we have done till now, we can talk about it then. But if everything is clear, then that's great. You can let me know about it, and if there is any doubt, you can even mention it then. So, we will be continuing the discussion about the important questions and the concepts now. But before starting the discussion, I need to show you some of the important slides, and after that, we will be continuing the discussion too. So, have a look at the first one, which is going to be regarding the Unacademy Learning app. The next we are going to have is this one. Okay, that's going to be the another important slide, and the next something about me. And here we are gonna have is the community feature which is there on Unacademy Learning app, which will be helping you to get new updates, latest updates, and to get the information about the other important things. So this is how, guys, everything will be helping you a lot. Give me a second. Okay, it's here. Done. So actually, this is how you can consider all these important things. You can get to know about the important information and updates. Now, next we are having here is this slide, where like you can see there are going to be the details about the iconic subscription, what are the benefits you will get, and how it will be helping you. Even now the notes are available on the learning app, which will be helping you a lot to take your preparation to the next level. And next we are going to have the referral code mentioned here, which will be helping you to get the discount in the total subscription amount. Then, so that's how, guys, you can get all these benefits if you will be proceeding further to take the subscription. And even if any of your friends will be taking the subscription, let them know about it. Clear? And you can even share the code with them so that they will be able to like get the discount as well. In upcoming days, so many new courses by the top educators will also be starting on Unacademy. So if you don't want to miss them, you can take the subscription and start your preparation under the guidance of top educators. This is regarding the plus subscription. What are the benefits you will get if you will be taking the plus subscription? Okay, all that has even been shown here, and even the notes are available on the learning app, which will be helping you to take your preparation to the next level. The referral code has been mentioned, which is Anjali Alive, so which will be helping you to get the discount in the total subscription amount. Light subscription details are here. The difference between plus iconic and the light subscription has been shown here. Also, guys, you can use and apply the code Anjali Live whenever you will proceed further to take the subscription and get the discount in the total subscription amount. Now we will be proceeding further to do more discussion, and we will be taking the important questions and the concepts here in the session. So if in case you will be having any question, query or doubt anywhere, you can let me know about it, and we will be trying to consider that. Let me just take the first question right now. Just a second, I'm gonna write the first one here. And I hope whatever we have considered in the last session, guys, that will be clear. But still, if you will find that something is not clear to you or somewhere there is doubt, just mention it. We will be talking about that. The first one is quite simple and easy. Let's have a look at this. The value of Try it now and let me know as you will get it done. I think this will be quite simple and easy for everyone to consider. Even we'll be taking other different concepts based questions here as well. But yeah, start working on it. Let me know whatever is the right answer according to you. So the value of the Landesi factor you have to find for a fine structural level defined by the quantum numbers L is equal to 1, J is equal to 2 and S is equal to 1. So here you need to know about the like formula for the Landesi factor. If you know that, I think it's gonna be quite simple and easy for you to consider it, which is 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 upon 2J into J plus 1. Okay, so next is going to be, just you have to put the J, L and S values here. So when you will put them, you are going to get, like, this formula is important. And even I would like to share a trick here to memorize this formula. If you find it confusing sometimes to take the sign, to consider like what sign should be there, whether S is positive, J is positive or L is positive, whatever it is. Okay, so if you find it confusing, let me just tell you. So here you know J is equal to L minus S or L plus S, we know. Okay, now in this case what will happen, S, let's say, is representing strong. So when something is strong, when you will take it on the other hand, it will stay positive. So the L is low or weak, so that's why its sign is negative. That's how you can take the positive and negative sign for these cases, and I hope you will not be making any mistake anytime now. So it's going to be G is equal to 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 upon 2J into J plus 1. Done? Now the next thing is, if I'm going to talk about the next one, that's going to be J value 2. So you just have to put the value there. S value 1, you have to put it here. L value 1, like, you have to put it here. And 2J into J plus 1. That's how you can consider it. Done? Another thing is, that's going to be G is equal to 1 plus this, like all these things we are going to have. Now next thing is, if we will go for the next point, that is, just consider the values, put the values, simplify or solve it, you are getting your answer. So that's it. This is how you can get the answer. If you are gonna get it, just mention it in the comments. What will be your right answer for this question? Let me know. Okay, so if in case there is any doubt, just mention it, but if it is clear, that's great. Now I'm going to give you the next one too. That is, the separation between the adjacent levels of a normal multiplet are found to be 22 centimeter inverse and 33 centimeter inverse. Assume that the multiplet is described well by the LS coupling scheme where A is a constant, the term notations for this multiplet is options are 3F234, 3G345. Next is 3D123. Try it now and let me know as you will get it done. What will be the right answer according to you? But in case if you will be having any doubt, we will be talking about it then. And if you're gonna get it, that's great. So start working on it now. And just in some time, I'll be starting the discussion about it too. Try, and let me know. Tell me. Look at this. Because nobody has mentioned the answer in the comments till now. So what we will do, we are just going to talk about the steps now. And I will be telling you that how you can proceed further or what you have to do to get the answer or how you will understand that how to take the steps. So the separation between the adjacent levels of a normal multiplet are found to be 22 centimeter inverse and 33 centimeter inverse. Okay, the separation between the adjacent levels of a normal multiplet are found to be 22 and 33 centimeter inverse. Assume that the multiplet is described well by the LS coupling scheme and the Lambda interval rule, that is namely EJ minus 1 is equal to AJ, where A is a constant. The term notation for this multiplet is, okay, so what we can do, let's say we are going to consider EJ minus 1 to be equal to AJ. So what will happen in this case? It's going to be, we are going to have, let's say 22 centimeters. So J values, we can consider 3 J values. J, J minus 1 and J plus 1. Clear? So what will happen in this case? They have mentioned J and J minus 1 energy differences. So J and J minus 1 will give us AJ, that's it. And the other equation I will make is EJ plus 1 minus EJ in the similar manner, the greater value and the smaller value. AJ plus 1. Okay, you can have a look at this. This was larger value, this was smaller value, so AJ we got. Same way, J plus 1, J, so we will be getting J plus 1. So these two equations we had. The first one will be giving us 22 centimeter inverse and the second one will be giving us the 33 centimeter inverse. Now what will happen next? The next thing is, once you are considering it, what you can do? You can divide this equation by this. So you will be able to get J upon J plus 1 is equal to 2 upon 3. So 3J is equal to 2J plus 2. And next is going to be, you got J is equal to 2. Once you got it, what next we will consider? That's going to be 1, 2 and 3. Okay, that's how you can just get it. And now once you got it 1, 2 and 3 here, you have to see in which option, like they have shown you the same J values. So that's option D, and your right answer will be option D then. This is how you will be just getting the answer, or you will be proceeding further to get the answer, okay, for any such type of question. Let me just give you the next one, but in case if there is anybody having any doubt right now in this one, you can just tell me, we can consider that part. But if everything is clear, that's great. So let me know if any doubt is there, or anywhere you are not able to get something, we can surely consider it. But if everything is all right and clear, that's great. The G-min shift. Next question. The G-min shift of the energy of a state with quantum numbers L, S, J and Mj is H Z is equal to Mj mu B upon J into J plus 1. L dot J plus GS, that will be S dot J, where B is applied, B is the applied magnetic field, and GS is the G factor for the spin and mu B upon H is equal to 1.4 megahertz G inverse. Okay, next, where H is the Planck constant, that's a small h. H is the Planck constant the approximate frequency shift of the S is equal to 0, L is equal to 1, and Mj is equal to 1 state at a magnetic field of 1 G is. Options are 10 megahertz, 1.4 megahertz, 5 megahertz, 2.8 megahertz. Please let me know as you will get it done. If in case you will have any doubt, you can let me know about it too. So in this case, they are talking about the Riemann shift. Okay, the Riemann shift of the energy of a state with quantum numbers L, S, J, and Mj is Hz is equal to Mj mu b b upon J into J plus 1, the complete expression which has been given, where B is the applied magnetic field, Gs is the G factor for the spin, and mu b upon H is this. So where H is the Planck constant, so the approximate frequency shift of the S is equal to 0, L is equal to 1, and Mg is equal to 1 state at a magnetic field of 1G is. So in that case, what will happen? We can simply consider it, that's going to be, we are having the frequency shift formula because they have asked for that. That is EB is equal to 4 pi m. Clear? So in that case, if we will multiply with h and divide it by h, we will be having EH upon 2m or EH squared upon 2m B upon h. So EH upon 4 pi m is nothing but it's going to be 2m only, not pi. So it's 4 pi m now we will have in the denominator. It is going to be mu b upon h into b. Okay, mu b upon h is what? 1.4, and b is what? It's 1. So 1.4 multiplied with 1, and that's going to be 1.4 megahertz. That's how your option B is going to be the correct one. Clear? That's how you will be solving it and you will be able to get the answer now. Let me know if in case there is anybody having any doubt, we can talk about it. Or if there is anybody like is confused about the formula, the steps or anything, you can just let me know. We can consider that part too. But if everything is getting clear, that's great. We can go for the next question. An atomic spectral line is observed to split into nine components due to Riemann shift if the upper state of the atom is 3d2, then the lower state will be. Options are 3f2, 3f1, 3p1, and the next one is 3p2. You can start working on it and let me know whatever is going to be the doubt you will have there. Like, we can talk about it, and if everything will be clear, that's great. Let me know. Let me know about it if there will be any doubt. Otherwise, in just some time, I will start doing the discussion about it. Done? Done. I'm just gonna see if you will get the answer. Option B. Let me just see. Oh, no, it's not gonna be correct. But I'll be telling you how you can find the right answer. Thank you so much, Rajesh. And what are the steps you have to take to get the answer. So we'll be talking about the steps too. See, an atomic spectral line is observed to split into 9 components. Clear? So this is going to be the first hint. Due to G-mean shift, in the if the upper state of the atom is 3d2. So let's say this is going to be one of the J values we had as 2. Okay, now the point is to know about the components, like 9 components are there. There is a formula that is 4J1 plus 2J2 plus 1. So J1 here must be less than J2. Clear? So what will happen in this case? You can see the options. You are having either the other J value allowed as 1 or 2. Okay, so if I will see the given value, it's 2. So I'll be putting it here 4 to the 8. No, smaller value. So if I'm taking the second value to be 1, so I have to take 1 at place of J1. So 4 ones are 4 plus 2 to the 4 plus 1. That's giving me 9. But if I will take the other value to be 2 as well, so in that case, I will not be getting 9 components. Means I will have either B or C, any one of them as the correct answer. But now I have to check that which one will be correct. So if you will see this notation 3F1, in this case you will find that the 2S plus 1 is equal to, that's going to be 3. So S is equal to 1 you will have there. Done. And the other thing is the L value for F is SPDF 0, 1, 2, 3. So L value is equal to what? 3. So J is equal to L minus S to L plus S, which will be 2, 3, 4. Okay, now you can see for 3F1 notation, you are not getting the J value to be 1. You are getting 2, 3, 4. That's why it is the incorrect answer, and the only correct answer will be option C. Because even if you will worked on 3P1 notation, after simplifying it, you will be able to get J is equal to 1. Is it alright and clear to everyone? Okay, so that's how we can consider it. Let me know if in case there is any doubt anybody is gonna have, we can talk about that. But if it is getting clear now, that's great. We can go for the next question too. So the another question we will have is, I'll be writing it here. Give me a second, let me just work on this part. So the next is, in the LS coupling, scheme, the terms arising from two non-equivalent p electrons are three S 1P 3P 1D 3D 1S 3S 1P 1D 1S 3S 3P 3D. Next one is 1S 3S 1P 3P 1D 3D. Now you can start working on it and tell me what will be the right answer according to you for this question. If in case you will be having any doubt, you can let me know about it. We will be trying to consider it then. If anybody is there like who is gonna get the answer, tell me what do you think will be the correct answer for this question, and if in case you will have doubt, we can talk about it. So two non-equivalent p electrons they are talking about. Can we take it to be 2p 3p like this? Okay. Now in this case what will happen, it's going to be L1 is equal to 1, L2 is also equal to 1 for p orbital. So L value will be net will be L1 minus L2 to L1 plus L2, that is 0 1 2. If we will talk about spin, it will be 1 upon 2, and the another case it will be 1 upon 2 as well. Next S will be S1 minus S2 to S1 plus S2, that is 0 and 1. Let me know if in case there is anybody having any doubt. Another thing is, if we will talk about the next part, that's going to be, you will be getting the J values, which are L minus S to L plus S. But if you will start working on finding J values like this, you may find it complicated. So it's better to make the table once that will be having the L values in it, 0 1 2 0 1 2, and S values are 0 0 0 1 1 1. J will be L minus S to L plus S, that's going to be 0 1 2 1 0 1 2, L minus S to L plus S, all values we will be taking 1 2 3. Now 2s plus 1 Lj you have to consider there, and you can see what terms you will be getting in this case, because they have just mentioned the options with the 2s plus 1 L value, so that's how we will be just writing that. So 2s plus 1 L is S, 2s plus 1 L is P, 2s plus 1 L is like 2s plus 1 will be 1, and then for 2 D, and 2s plus 1 it's 3 S, 3 P, and 3 D. So 1s 1p 1d, 3s 3p 3d, that's it. So all these you are getting, and that same as option D, hence your right answer will be option D for this question. Tell me if in case there is anybody having any doubt, we can talk about it, otherwise I'll be giving you the next question now. So you can even mention if in case there is anybody having any doubt at any point, we can talk about it, but if everything is clear, that's great. So in a normal Riemann effect, experiment using a magnetic field of a strength the splitting between the components of a 660 nanometer spectral line is. Options are this is 10 picometer, next one is 8 picometer, next one is 6 picometer. Start working on it. Let me know what do you think will be the correct answer according to you. If in case there will be any doubt you will have, you can surely let me know about that. We will be trying to consider it, but if everything will be clear, that's great, great, great. Try it now. So in a normal Riemann effect experiment using a magnetic field of strength, that is B value is given 0.3 Tesla, the splitting between the components of 660 nanometer spectral line. So this is going to be what? is going to be your wavelength of the line for which you want to find the splitting. So now the wavelength splitting is what? The formula for that is delta lambda is equal to lambda square upon c EB upon 4 pi m. Okay, so in that case what will happen, like once you're gonna just put all these values given to you, lambda that is 660 nanometers converted into meters, E that is charge on electron which is 1.6 into 10 to the power minus 19, B which is 0.3, 4 pi as it is like 4 into 3.14, M is 9.1 into 10 to the power minus 31, okay, and C is 3 into 10 to the power 8. So by putting all these values and by having the values as in the units which is mentioned in the option picometer, you will be able to reach to the final answer. So you just have to work on the calculation part now and you will be able to get it. But in case still if you will have any doubt, we can surely talk about it. So let me know if in case there will be anything not clear to you. Done? So tell me if in case there is anything not clear or anywhere there is any doubt, we can talk about it. And just whatever doubt related to discussion you will have, you can mention it. Okay, we will be talking about that. So do the calculation and let me know if in case there will be anybody having any doubt, we will be considering that point. Otherwise we will go for the next question. I think guys, after calculating you will be getting some value closer to the value given in option D or exactly the same. So that's how you are reaching to the final answer. Now I'll be giving you the another question too, but let me know if in case there is any doubt anybody is having in that part. The question is, the ground state I'm just going to write the rest of the statement there. Give me a second. Give me a second, guys. Okay. Okay. So the ground state electronic configuration of 22 titanium is which state in the standard spectroscopic notations is not possible in this configuration. I'll be writing the options too. Give me a second. 1F3, 1S0, 1d2, 3p0. You can try working on it now and let me know as you will get it done. So the ground state electronic configuration, that is 22 titanium, is this. Same as argon, but two additional terms. You can see 4s2 is completely filled, so it will be the term you will have earlier and then 3d2 later on, which is state in the standard spectroscopic notations is not possible in this configuration. That's your question. So just have a look at this part and work on the process like which you have to follow to get the answer. If in case there will be anybody having any doubt, we can surely talk about it, but if it will be getting clear to everyone, that's great. Otherwise I will be explaining each and everything you need to know to get the answer. Okay, let me know if there is anything not clear or anywhere there is any doubt. Try considering it and let me know as you will get it done. Okay, give me a second. If you are getting it, guys, just mention what would be the right answer according to you. Otherwise, I'll start the discussion about it. So if you will see, they have mentioned the ground state electronic configuration of titanium is this, which is state in the standard notation, spectroscopic notation is not possible in this configuration. So if I will talk about the spectroscopic notation, like the terms you have to write, look at the electronic configuration given to you for that. S2 is completely filled, you don't have to worry about it. For D2 you will write it. So there are two ways for the equivalent to electrons cases we can consider. One is the trick, which can help you to find the spectroscopic term notation, and the other one is the Bright's scheme, which is like the proper method we work on. So what we do for the proper method, like we draw the structure like this, ml1 and ml2 you will write since it's d2, so L value will be equal to 2 for it, SPD 0 1 2. The ml values will be here +2, +1, 0, -1 and -2, +2, +1, 0, -1 and -2. You just have to add the respective values and you will be able to get it done. Just a second. Give me a second, guys. Okay, so in this case, when you are gonna get it done, it's the Bright's scheme I'm talking about right now. Give me a second. Okay, just add it and write all these values here. Okay, so you will be having 2, 3, 2, 1 and 0. Okay, 3, 2, 1, 0, -1. Next is 2, 1, 0, -1, -2. Next is 1, 0, -1, -2, -3. Next is 0, -1, -2, -3, -4. Now you can see there are some of the values you can see on the principal diagonal positions. And for those values, the ml1 and ml2 both will be same. These are for 2 electrons. So ml1 and ml2 for this 4 is same, plus 2 plus 2. For this 2, it will be same vertically and horizontally. Same way for all the principal diagonal elements. So we know, as per the Pauli's exclusion principle, we can't have the 2 electrons having the same spin in the same state. We can't have them. Okay, if they are in the same state, their spins must be different. So for these ones, the opposite spins we should have, because the states are same, the ml values are same. So in that case, what will happen? The ml1 and ml2 are same for these ones, so spins must be different. One positive, another negative you have to take. So the net spin for these values 4 to 0 must be s is equal to 0. And then you have to consider for the other, that is 1, 3. Okay, 1 and 3 are remaining. So for them, the spins can be same because they are not present in the principal diagonal and their states are like not same. So in this case, your s value will be equal to 1. Now, if we are going to talk about this part, so you will be making the table, like L value you will write and then S value you will write. So L value is what? 0, 1, 2, 3, 4. You can see the maximum value in this configuration is 4. So for the 4 to 0, you got the spin must be 0. And for the other cases, the spin must be 1. So what will happen then? In that case, J will be equal to L minus S to L plus S. This is how you have to write it. So this was the detailed method, which is the Bright's scheme. But if I will talk about the another one, so in that case, what will happen? That is just simply you have to see L is equal to 2. And the trick is just applicable for the 2 equivalent electrons. In this case, L is equal to 2 will have what? 2 into 2, because 2 electrons are there. L is equal to 2 for d orbital. So 2 into 2 is 4. So which will give you 0 to 4. Okay, which is going to have the 0, 1, 2, 3, 4, these values which you got from the Bright's scheme too. Another thing is, here you have to consider even L values will have the even spin, which is 0, and the odd L values will have the odd spin, which is 1. So this is how you can simply consider the spin corresponding to different L values, and that's how you will be able to get the J value too, and that's how you will be able to find it. Let me know if in case there is anybody having any doubt, we can talk about it. But if you're getting it, guys, this method or this trick works only for the 2 equivalent electrons and not for any other case. Okay, it can give you all the spectroscopic terms. So you have to just use any of these methods to get the answer for this one, and you can see which one is not the possible term there, and that's your answer. Tell me if in case there is still any doubt anybody is going to have, we can talk about it. But if it is getting clear, that's great, great, great. I'll be giving you the next question then. One is 0. Next one is 3s1, 2p 3 by 2, 2p 3 by 2, and 3s1. Okay, next is 1s0, 2p 1 by 2, 2p 3 by 2, and 1s0. The next one is 1s0, 2p 3 by 2, 2p 1 by 2, and 3s1. Try it now and let me know as you will get it done. If in case you will be having any doubt or difficulty in considering this part, you can let me know. Try it now, guys, and let me know whatever will be the right answer according to you. If in case you will be having any doubt anywhere, we can consider it. Try. Let me know if in case you're gonna have any doubt. Tell me, guys, if you're getting it, you can mention your answer in the comments. If you're not getting it, we can talk about it then. Okay, so basically in this case, you can see that 12 magnesium, 13 aluminum, 17 chlorine, 18 argon. First of all, you have to write their electronic configurations and then you will be able to proceed further. So if I'm going to talk about the electronic configuration, for this one, you will have the last term as 3s2. For this one, you will have the last term as 3p1. For this one, you will have the last term as 3p5. And for this one, you will have the last term as 3p6 if you will write their complete configuration. So I'm even going to tell you for aluminium what will be the all terms you will have in the configuration. If you want, you can note it down. So 1s2, 2s2, 2p6, 3s2, 3p1. Oh, not for, for aluminium, right? Now for magnesium, it will be 1s2, 2s2, 2p6, 3s2. And for the chlorine, it will be 1s2, 2s2, 2p6, 3s2 and 3p5. So next one is 1s2, 2s2, 2p6, 3s6, 3s2 and 3p6. I'm just going to write for argon. So 1s2, 2s2, 2p6, 3s2, 3p6. Okay. Now you can observe one thing, that this and this, the last terms of these two configurations are completely filled. The s2 and p6. When they are completely filled, we know that the spectroscopic term notation for the completely filled electrons are 1s0. So it means that option C will be correct even if we are not working on the other two, because only in one option the first and the last one is showing you 1s0. So that is going to be your correct answer, and that's your option C. You can tell me if in case there is still anybody is having any doubt, we can talk about it. Otherwise, we'll be taking the next question here. So let me know if there is anything which is not clear to you or anywhere you are having doubt. We can talk about that part as well. Otherwise, here is the next question waiting for you. Okay. Let me know. If there is any doubt. And if everything is clear, that's great. So tell me, guys, do you want me to consider more questions or should we keep it this much? I think we can take one more. But yeah, if you will have any doubt or difficulty in anything we have considered till now, even you can tell me that. We can talk about that part too. And if everything is clear, that's great. So let's take one question from this topic, which is another very important topic. It is the first Stokes line of a rotational Raman spectrum is observed at 12.96 centimeter inverse. Considering the rigid rotor approximation the rotational constant is given by options are 6.48 centimeter inverse, 3.24 centimeter inverse, next is 2.16 centimeter inverse and 1.62 centimeter inverse. These are the different options we are gonna have. Just try considering it and let me know, as you will be getting the answer for this one. So basically guys, if you have prepared the topic and you know about it, it will be quite easy for you to work on this part. But if you are not familiar with it, you can find it difficult too. So they have given the first Stokes line of a rotational Raman spectrum is observed at this. So first Stokes line we get at the 6b separation, where b is the rotational constant. So that's how you just have to equate it with 6b and you will be able to get 2.16, which is your option C, and that will be the correct one. Just having the knowledge about the topic can help us here a lot to work on this type of question. Okay, I hope each and everything is now clear to every one of you guys, but in case if there will be any doubt you will have, you can surely mention it and let me know about it. Also guys, we will be keeping it this much right now in this session. I'm just going to show you the slide having the information about the iconic subscription, the plus subscription, light, and the other like the difference between the plus iconic and the light subscription. Okay, that's great. So guys, you can see all the benefits you will be getting if you will be taking plus iconic or the light subscription. Even now the notes are available on the learning app, which will be helping you to take your preparation to a very good level. One more thing I would like to tell you here, that is that in upcoming days so many new courses by the top educators will be starting on Unacademy, which will be helping you to take your preparation to a very good level. So let's keep it this much right now in this session today. And thank you so much everyone for joining the session and for attending it till the end. Thank you. Let's keep it this much. We will be having more important sessions in upcoming days. You all can join